Hey, good morning. What day is today? Wednesday. Anyway, just trying to get some more material off to you. I'm going to take a couple days and probably not put anything up for a while because I want to spend a little time enjoying summer. So I figure we'll take maybe about a week off and then pick up with some other ideas. Again, my idea of summer work is to just get you prepared for what we're going to learn and to make the learning go more quickly and of course, to get you familiar with some of the vocabulary of chemistry. And today it's a very important topic, though, and this is one that you should not neglect. And I would like you to go to the online textbook. I've posted the link and read the section on writing and balancing chemical equations. Writing and balancing chemical equations is extraordinarily important because it is the basis of what we need to do to learn something called stoichiometry. And stoichiometry is just some mathematics involving chemical equations that enable us to make certain predictions about how much product we're going to form, how much reactants do we need, etc. So anyway, let's take a look at the significance of a chemical equation. And here we have, this is a combustion reaction. This is methane, CH4, and this is what the molecule looks like, because don't forget, these formulas represent either molecules or ionic compounds. So I have one of these CH4 molecules reacting with two molecules of oxygen. Now, oxygen, let me see if I can do this here. Oxygen, you see, is written as O2. And O2 means that in nature, oxygen comes, I'll just try to sketch it out like that, as a package. Two oxygen atoms combine together to form an oxygen molecule. So in nature, you're going to see O2. This is called a diatomic. Homonuclear means the same atoms bonded together. Homonuclear diatomic molecule. And on the periodic table, we have several of these. We've got Br2 is one of them, bromine, iodine, nitrogen, N2, chlorine, hydrogen, oxygen, and fluorine. So in nature, this is the way these atoms, excuse me, these molecules are found. The atoms on the periodic table, bromine, for example, Br, actually is Br2 because they're bonded together. And there's a reason for that. And when we get into bonding, we'll see that. There are a couple other ones that in nature occur as polyatomic, and we have P4, that's phosphorus. So when phosphorus is found in nature, it doesn't occur as just phosphorus atoms, it occurs as this P4 molecule. And S8, sulfur, actually forms an like eight sulfur atoms, 1, 2, 3, 4, 5, 6, 7, 8, some sort of a ring structure like that. Anyway, those are the uh, diatomic and polyatomic uh, molecules the way they occur in nature. So when you see something like O2, that's why it's written as O2. Anyway, on this side, on the left-hand side, are the reactants. So those are the things coming together to form, you guessed it, products. So we have a chemical reaction written out in chemical symbols, CH4, one molecule plus two molecules of O2 to give one molecule of CO2, carbon dioxide, and two molecules of water. We're going to spend some time learning to name before the end of summer these uh, molecular compounds, covalent molecular compounds. Not today, though. I just want to talk about these balanced chemical equations. But so when you read it like this, it really represents this down here, these molecules reacting. And notice one thing, we have to have the same number of atoms of each type of atom on both sides of the arrow. This is conservation of mass. You can't just lose things. You can't say, well, I've got 4 hydrogens on this side and I only need 2 on that side. No, no, no. Everything has to be conserved. So if you notice, the black ball here is a carbon. I've got one of them. I've got one on the product side, so that's good. I've got 4 white balls here. That's the hydrogen. And on this side, I've got 1, 2, 3, 4 white balls, 4 hydrogens. And on this side, I've got 1, 2, 3, 4 red balls, 1, 2, 3, 4 red balls. So they all go ahead and add up. We have the same number of each type of atom on both sides. Now, how do we go ahead and represent this in an equation? We use coefficients, and those coefficients are meant to balance the number of atoms. You never change the subscripts. The subscript, if you change the subscript, you're changing the molecule. So let's go back to my notepad here, or my scrap paper rather, and let's look at something. Let's look at N2 plus H2 to give NH3. This is a real famous reaction, and it's the synthesis of ammonia. Nitrogen plus hydrogen to give ammonia. And if we want to draw a picture, we can draw a picture. We can say, all right, I've got N2. I'm just going to represent that as two balls connected by a bond. Really, it's a triple bond, but we're not going to worry about that right now. And then I'm going to say, all right, we've got H2, and I'll make those black or blue, whatever color this pen is. This is supposed to be green. And let's draw an NH3. Well, an NH3 is going to have a green ball and again, this is a very elementary looking cartoon here of this reaction. But let's take note of something. I've got 2 green balls on this side, 1 on that side. I've got 2, I guess they're blue or black, I can't tell, balls on that side and 3 on that side. So something doesn't add up here. We don't have the same number of atoms of each type on both sides. So we have to use, we have to go ahead and use coefficients. We cannot change the subscripts. So, perhaps the easiest thing to start out by doing is saying, well, I'm going to put a 2 here. All right, so I can draw another one of these guys. Oops, losing my pen. I'll draw another one because now I put 2 there. All right, now the green balls, 2 and 2, were perfect. But I've got 1, 2, 3, 4, 5, 6 hydrogens now. So what am I going to do? Well, I'm going to put a 3 here because 3 times 2 is 6. 2 times 3 is 6. 2 times 1 is 2. I've got 2 on that side. So everything is balanced. And that's what you're going to need to do when you start looking through these equations. So let's go ahead and look through this section of the chapter. I would like you to read through this, and I would like you to go ahead and just go through, and it's a very easy read, nothing exciting. Make sure you pay attention to the examples, and just go through and look at this section on balancing chemical equations. And let's see if there are any exercises you might want to try. Yeah, we can take a look at question 3 here underneath the exercises. That's what I love about this online textbook. I mean, it just boom, right at your fingertips. So take a look at some of these, give them a try, and then next week when I come back, we can go ahead and go through these on a video step by step. This is definitely one thing. If you can walk away from the summer learning about naming things, naming ionic and covalent compounds, balancing chemical equations, understanding the idea of the mole, which we'll get to, and understanding the concept of atomic structure, that's a really good starting point. So anyway, that's about it, and I hope that you have a really great rest of the week and weekend, and we'll pick up again on Monday. Or wait, we'll pick up again next Wednesday. We'll take a week off. We'll still read the chapter though. All right, take care.